What about these smart contracts? So a smart contract is a loan contract that's coded right into the blockchain, and it's called a funding account. That's what we call it. This means every 4 days you will have earned 1 plus compounded profit, because the profits are compounded daily. So when you get a chance, talk to a live NexGen smart contract professional and see how to secure your smart business loan from NexGen.
Blockchain and distributed ledger technologies enable people to interact in a peer-to-peer way without going through a trusted intermediary. This innovation makes it possible for us as a society to organize collective governance in exciting new ways. But it also poses challenges to our existing governance frameworks. I had a chance to sit down today with Vitalik Buterin, the inventor of Ethereum, to delve into this topic. When you first started Ethereum, what was the philosophy with which you started it? So you set out to build something, you wanted to do something that was Turing complete, because you wanted to be able to build this sort of world computer, general purpose blockchain, instead of something that was limited to just a certain set of transactions like Bitcoin.
Yes.
So for people who don't know what Web3 is.
Web3 is this vision that Ethereum plus a combination of several other technologies can bring about a more kind of decentralized internet that puts basically more control in the hands of the user. And this is a suite of technologies that includes Ethereum as a kind of decentralized database, Whisper as kind of decentralized messaging, Swarm as decentralized content hosting, possibly other technologies as well. And these things will be developed in some ways together, but designed to be nicely complementary with each other. And you could see a lot of applications using some combination of both.
What about the infrastructure environment, hardware requirements and things?
Well, one of the things I actually love about blockchains is that they can survive without needing much special hardware. So like I personally just actually really love the idea that basically the thing could just run on a few thousand guys with their regular laptops. That's one of the things that really excited me about Bitcoin early on. It doesn't require all of this $1 billion of capital started up by people who are already here before, and that would be basically impossible for any new group to match. It's just, like a few thousand people on their laptops is all that you need.
With respect to hardware, what about people who are not going to have laptops, but just smart devices?
Look, one of the things that we kind of deeply cared about from the start, especially for people with laptops, is a very strong light client technology. So this basically means that you can use this technology to have a client that runs on a phone, which has almost the same levels of security and trustworthiness as a regular client, except it's vastly more efficient.
And you can do that in Sudan. Where you have people with pretty
probably
basic phones.
Not Sudan now, but probably Sudan in 3 to 5 years. Yes, like people do underestimate, I think, just like the sheer level of mobile penetration and like how quickly it's growing. I think once all of these places have internet access, and once they get up to basically once the quality of $20 phones increases by another couple of years worth of time, it'll definitely be at that point.
So you genuinely think that Ethereum is going to be a worldwide penetrating technology, and that we're not going to be limited by bandwidth and hardware? That's
definitely what we hope. I mean, like if blockchains were only usable by the rich, then the whole space would definitely be much less interesting.
So how are you thinking about the incentive structures that you're building in, particularly with the upcoming transition to Casper, proof of stake? There's a lot of skepticism, as I'm sure you know, that there's just going to be this massive centralization around people who already have huge stakes being able to control the network. Obviously, this is not something that surprises you and that you're planning for.
I mean, it's definitely kind of another sort of devil argument, because like with proof of work, you notice that 70% of mining is done out of China, 70% of mining is done using mining hardware created by one company and run by basically 5 or 10 guys. And like the thing with hardware centralization is that it's the sort of thing that is in some ways much harder to dislodge, right? So like in Casper, for example, there's a mechanic where even if a group of people that have more than a third of the deposits collude and they do an attack, then basically the mechanism penalizes them, and once the attack is detected, it takes away their money, and so they don't have the money to do the second attack anymore. But with hardware, you can't really do that. Like you can't, there's no way to kind of burn a piece of hardware from inside a protocol. From my kind of point of view of someone who has really deeply thought about these protocols, I think that proof of stake kind of is better on a bunch of dimensions. And Like the kind of meta argument that I use to explain this is basically that because proof of stake has to do with virtual assets that are defined inside the system, it means that you have a lot more freedom in basically determining rules that are optimal. And so we can design systems that, like in general, have much better incentives, like better structured rewards and like larger penalties for misbehavior and so forth. Whereas with proof of work, you're kind of stuck with the laws of physics in some ways.
Well, there's also this transition plan in place, right? So we're combining proof of work and proof of stake for a certain period of time. And you're doing analytics on that to see what's happening as it evolves. Obviously, you can pull back if you need to. But that's a pretty technical topic. So for CG viewers who don't really know that much about the details of how, let's talk about a different internal governance aspect, which is how decisions about changes to the protocol are made. Currently, in Bitcoin is done through mining, essentially, because the miners decide which version to accept. There are different mechanisms in different chains. We saw, Tezos launch earlier this year, or ICO anyway, with the idea of building a different kind of a governance system or decision-making system about protocol changes. There are several other protocols working on different models, and some people say, hey, everybody who uses the system should get to have a democratic say in protocol changes, but reality is most people are not developers. They don't know the details enough to be able to really have an informed opinion about stuff. And it's just like in our societies where we have rational ignorance about a lot of things, and people don't want to invest their time in trying to figure out what they want to vote on in this kind of an internal governance scheme. How do you think about this problem? Who should be able to decide?
Governance ultimately is like basically the set of kind of institutions and norms and agreements and kind of standards, like what economists call Schelling points around, like basically under what contexts should people use these underlying tools and in what ways. In like the physical world, you would have like parliaments and constitutions and laws and so forth, and you would have also on top of that often very informal norms about like the ways in which different things should be used.
Social norms.
Yeah, exactly. And in the crypto world, I think you basically you have some of the same thing, right? So you have at the very bottom level, like people's ability to write software, miners' ability to mine on particular chains, and at the higher levels, you would have developers discussing between themselves, developers implementing software, developers coming up with mechanisms between themselves to agree on like basically what the software changes should make, like what block they should activate at, under what conditions they should be agreed on. And you would have users ultimately always have the ability to basically just rebel and refuse to accept a particular update. And then on top of that, you would also have norms and expectations about what kinds of updates should happen in general. So for example, in Bitcoin, people really cherish the 21 million limit. There's also the ideas of decentralization. There's the idea that this thing is supposed to be a currency, like you're not supposed to arbitrarily take money away from people. So basically, if a user finds something distasteful and there is a norm against it, then the user knows that a lot of other people find it distasteful as well. And they also know that because there exists this kind of, like meta-level social object called a norm, there, like other users will also be more interested in coordinating around basically not accepting the update. And so users are going to rebel, not install a software, and you have things like Ethereum Classic.
Sure, and there are a lot of really well-known and well-documented sort of human rationality errors.
Yes, totally.
So, I mean, all kinds of biases. If you just go to the wiki page for cognitive biases, you get this list of like 60 now, and including things like we've changed the way that we remember information because of the Google effect, that we tend not to even bother to remember things that we can easily look up on Google nowadays. And so the way that we interact with technology is actually changing our human thinking biases as well.
Yes.
How do you plan for those and design those in?
This is one of the reasons why the economics of crypto economics is so interesting, because like some people say that, crypto economics is not going to work because people are not fully rational or people are not purely motivated by economic factors. But what people don't see, I think, is that even though economic incentives are not the only thing that motivates people, they are a very large thing that motivates people.
Yeah, but there's a difference between motivating people with economic incentives and being able to understand how they will behave in reaction to that incentive. Because sometimes people could take completely irrational strategies.
Yes, right. But practically speaking, like the idea is that it's easier to predict the idea that people are more likely to take things that will make them more money than it is to predict that any specific bias is going to be very stable and robust across decades and across different cultures and across being the actors being people versus organizations versus robots. So that's kind of probably one factor. And another factor that people miss is that it's not just about incentivizing people, it's also about this idea that basically, like, if you try to break Casper, then you lose a lot of money.
Right.
And so even if you're an irrational actor, if you have some particular amount of money, well, you can only do so much. There's a mathematical proof of an upper bound on like the ratio between basically how much harm you can cause and how much money you can burn in order to achieve it.
Right.
And so like using basically like economics as just a way of measuring actors in terms of the resources that they control is also just kind of another aspect of this.
There are a couple of things that have been sort of major topics of conversation around you in the last year, last month or so, couple of months. One of them is about, how much involvement should founders and core devs have in going around and evangelizing blockchain versus actually working on the protocol, doing things like meeting with world leaders. You caught a lot of flack for your trip to Russia, for example. Why do you do those things? How do you make decisions about how to balance your time?
Yeah, I think it's definitely, first of all, worth it to reach out and talk to people because, first of all, it helps people understand that, this is something that's concrete, that's got actual people behind it, and it's got legs, it's got potential. We're here to help humanity, and I think, just getting the understanding of that and just what the technology is and how it works is valuable. And
have you gotten the sense that people have understood that when you go to talk to world leaders?
I think
that
so.
We're here to help humanity?
Yeah, I think they have been definitely quite friendly in general over the last few years. And it's also important, I think, for us to understand them, right? And basically to understand, what are the challenges that kind of, basically mainstream institutions currently face, and what role can the technology have in addressing them. And, some of the conversations I've had, and probably this is more with banks than with governments, but to some extent with everyone, around what are the privacy challenges, why are they interested in consortium chains, what is their thinking about scalability. I think that's definitely all fairly important, and some of it definitely does end up kind of informing things that we focus on.
What are the things from your perspective in interfacing with the law, with governments, with regulators that are hindrances to what you're trying to achieve?
I would say the main kind of regulatory thing that's been a hindrance in practice just is difficulty of cryptocurrency exchange. Aside from cryptocurrency, so far there hasn't really been much hindrance to blockchain technology as a whole. But at the same time, public blockchains, despite being usable for a large number of things other than cryptocurrency, still fundamentally relying on cryptocurrency for transaction fees, economic incentivization, and a lot of other things. It would be so much better if people could buy $100 of cryptocurrency instead of $0 of cryptocurrency. And yet, in many places, it's still going from 0 to 100 is much harder than going from 100 to 5,000.
Right.
There's big differences between how politically easy it is to go after a technology where 90% of it is being used by terrorists versus going after a technology where going after something that's like the internet where yes, terrorists use it, but also the people who catch terrorists use it as well.
And have you in your sort of looking at different parts of the ecosystem around the world, are there certain areas parts of the world that seem particularly friendly or particularly hostile to Ethereum as an idea or as a project or as a decentralized model of organizing society? Basically,
the thing that you need, that I think a lot of people and probably even a lot of libertarians, even more than average, underappreciate is that very few people hate freedom. Basically, very few people hate privacy, very few people hate decentralization. Right. But there are a lot of people that find all of these things slightly valuable, but not too valuable, and they just come up with 1,000 exceptions for 1,000 different cases why, in this particular case, I want to have more control. Yeah. There definitely are places that have more of that than other places. So, on the one hand, China has had the ICO ban and the ban on most crypto trading, but on the other hand, there's a lot of other places that Switzerland, Singapore that have shown themselves to be very friendly. At the end of the day, nobody hates freedom and nobody hates privacy. Exactly. But a lot of people dislike uncertainty. Yes, totally. Yeah. And government is one form of certainty. Yes. Sort of the devil you know is better than the devil you don't. Definitely.
especially with a centralized mechanism like that, even just to handle Visa's throughput, let alone every imaginable smart contract, that's not going to work if everyone's running a copy of every program on their computer.
Yeah, totally. So, if you look at just the raw numbers of blockchains today, Bitcoin is currently processing a bit less than 3 transactions a second, and if it goes close to 4, then it's already at peak capacity. Ethereum, right, over the last few days, it's been doing about 5 a second, and if it goes above 6, then it's also at peak capacity. So, on the other hand, Uber on average 12 rides a second, PayPal several hundred, Visa several thousand, major stock exchanges tens of thousands, and if you want to go up to IoT, then you're talking hundreds of thousands. And if you want to go up to non-financial applications, so like for example, there's a platform called Leroy, which is basically just Twitter on the blockchain, then you're talking also about hundreds of thousands, possibly millions. So, there is a kind of gap from here to there. And I think right now there already is really a lot of institutional hype in the space and just public hype. So when you have, like Vladimir Putin having, knowing what blockchains and Ethereum are, and Paris Hilton going out promoting ICOs on Twitter, that's peak hype. But the reason, I think a large part of the reason why a lot of this hasn't materialized into action yet is precisely because of some of these technical obstacles that make blockchains, work okay for some niche use cases, but not really work well for mainstream use. Now, our team is working very hard on various kinds of scalability solutions. So you hear about buzzwords like plasma, sharding, state channels, write-in, there's, various newer ones like Perun. So, if all of these are various different ideas that actually do try to kind of break through this fundamental barrier, right? That try to either create blockchains that still maintain a large amount of security without requiring everyone to literally process everything, right? So if you think about it, like one extreme is one guy processes everything, which is today's world. The other extreme is everyone processes everything. Well, what if you can get like square root of everyone, so like maybe 500 people processing each transaction? You still get enough decentralization and security for everything you need, but suddenly it's, within it's efficient enough that it actually works for stuff in the real world. And the other kinds of strategies are strategies that try to use the blockchain in a kind of more intelligently, right? So it's basically, like one of the analogies that like Joseph Poon from Plasma uses a lot is the idea of the blockchain as a court system, right? So blockchains are great at securely resolving disputes, and currently the way the naive blockchain applications work is they just put every single transaction on the blockchain. But what you could do instead is you could have systems where people send messages that I call kind of tickets, so digitally signed messages that are off-chain by default, but where the blockchain only gets used in those specific cases where there's a disagreement. So like if I have 100 digital, 100 ether, and I send you the 100 ether, then that might not ever go off chain. But if I send you the 100 ether and then you claim that I never sent you the money, or I claim that I never sent you the money, then that's a transaction that I could, we have a dispute, and I could actually push it down onto the blockchain, and so we still have, a guarantee of security. Now, all of these approaches have their own trade-offs, and there's this huge amount of incremental technical work involved in figuring out what the right trade-offs are, but this starts looking like a direction that's much more promising.
And how far along are we? How long until you think that maybe we can scale to, as you said, hundreds of concurrent users? How many until we can replace Visa? How many until we can replace AWS?
I mean, for things like Visa, I think definitely, I'll say a couple of years. So maybe 1 year when we start seeing like prototypes that have, like a low security level, but are still, secure enough for like major organizations to start just doing proof of concepts on. And a couple more years for all these solutions to really hit the mainstream. AWS is a trickier one because there are reasons why blockchains are, no matter how good they are, never going to completely replace centralized cloud computing. And probably even more, one of the big ones, there's probably two big ones in my opinion. One big one is that there are computations that are intensive and that are hard to parallelize. So decentralized clouds are really good at parallelization because, you know, it's like Uber for your laptop. You know, you got millions of computers from, you know, millions of countries, millions of providers, all ranging all from individual laptops to, you know, you can think of, you know, even cloud computing companies basically turning into like specialized mining farms inside of the system. But if you have computations that require like a really large amount of serial computation, then that's harder to decentralize. And the second really tough one is privacy, right? Like if you have computations on private data, then there's basically two approaches. One of them is to make sure the computations are only done on hardware that you trust. And the second one is to use fancy cryptography. So, you know, you might have heard of buzzwords like homomorphic encryption and distinguishability obfuscation to do the computations. But then if you do that, then those tends to carry very serious computational efficiency trade-offs.
So basically for private or serial applications, you're going to do them locally?
Yeah, like in general, I think like there's always going to be this large set of applications where decentralized approaches like actually don't work that well, and that's fine. Yeah.